Thank you, everyone, for joining the Security Field Day. Really excited to join this, and this is my first time, as Tom mentioned, for Betacom to be here, and personally, being here as well. I've actually saw some of the Tech Day events as well, and was very impressed with the interaction and engagement that happened on the technology front. So I'll be taking the remaining of the time to talk about how we have adopted security, that's in cellular and into enabling private 5G as a service offering for Betacom. I actually have two sections. I've divided my presentations into two sections. First, we'll just talk about, in general, how we are leveraging cellular technologies and what security features come inherently in that. And my second presentation is going to be talking about how Betacom actually has evolved our efforts around that and how further secure that setup. So if you take a look at private mobile network, it actually leverages cellular technologies, right? So it does go ahead and actually leverages both 4G and 5G to enable the connectivity. As the question that Kristen actually had asked, like, what is it that actually enables the network? It's the cellular technology where we are leveraging CBRS band, as Brian mentioned, 3.55 to 3.7 megahertz. That's what we are leveraging to go ahead and actually enable that connectivity. Now, when 4G, which actually has been in place for over a decade or so, and 5G, as we are, starting to adopt that, we actually see the standards are developed with security in mind. So 3GPP, third generation partnership project that was out there to go ahead and actually talk about writing the specifications for the next generation technology, cellular technologies. I will just focus on the security aspect. They did, had their focus around security. They actually have written specifications around network access security in terms of how the communication between the user and the network access actually happens. How does the network domain security, which actually talks about how the backhaul in terms of the access between the radio and the core, and from the core to the other operator, or to the backhaul into the internet or to the application, how that's secured. User domain security is around how the user devices, the user itself, how the SIM itself, that security is actually addressed. And then application domain security goes on top of all of these three domains. And, which means, simply put, any application that's out there, they're built in security technologies from authentication, from integrity, and from privacy encryption standpoint, those are adhered to there as well. Last but not least, they actually have specifications around how all these features can be leveraged to go ahead and actually see, how they're configured and how they're actually implemented across the cellular framework. Another approach that's there with cellular is that you actually have granularity in how the network is set up and how you can go ahead and actually further secure the setup. What I mean is you actually have different elements from your device to the radio, to the core, and then to the network. And each of the elements, you actually have ability to go ahead and actually configure the setup to secure that communication for that. Let's say, when we say UE being the user equipment, that is talking to the radio, that communication itself, that you can secure that. How the radio then talks to the core, you can go ahead and actually further secure that. What it also means is that when somebody is trying to get into the setup, there is a multi-layer of access they actually have to get into, to really get into your network. It's, if you take a look at other communication technologies that are out there, you actually have one layer of access, and then you're pretty much in. And this, you actually have to get into different layers to have a complete access, okay? Just honing in on that multi-layered approach, as I mentioned, when you actually have the device and user device communication, now that could be your phones, the handheld scanners, the cameras, anything that's cellular enabled, you actually have communication between that and the radio devices that actually is done over a secure channel, which actually where the user is authenticated. Then there is an integrated check that actually happens for the communication, and from there on, the encryption actually happens over the setup. When it comes to the communication between the radio and the core, that actually is secured over IPsec. I mean, the standard IPsec that we all know of. And when it comes to communication between the core and our, the application layer or to the other operator, that actually happens over secure IPsec channel as well.
Question: what do you mean by secure device? How has my phone suddenly become a secure device?
Very good question. So, as I mentioned, that there are multiple layers of security that's actually enabled by 3GPP. When you take a look at your phone itself, the first level of security on your phone is how do you really actually access the phone by your biometrics, whether you're touching it or you're putting your PIN. That's the first level of security that's there on that device. Second, for your phone to go ahead and actually connect to the network, there is a SIM that actually goes into your phone to actually have it to be enabled to go ahead and actually talk to the network. If you don't have that SIM in there, then it's not able to go ahead and actually talk to the network. It's basically just a device where you can probably go ahead and actually maybe play a game, but not be able to really communicate. That's what I meant by security of the device. So again, you see two layers of security that was actually implemented on that phone itself.
So when you start talking about your SIM, what's on your SIM that's so special that it becomes part of my security?
So SIM, of course, SIM technology actually has evolved over the previous generations from, 2G to 3G to 4G to 5G, and each of the SIM that you actually have, it actually has a secure key and that secure key is on your phone, which you actually have. It never gets transmitted outside of your phone. It actually used to go ahead and actually build the different key exchange that actually leverages that secure key. Now, that same exact key is actually also stored on the core itself. And that's what allows for a secure communication to actually happen. So it's almost like a passcode that only your phone knows, and the enabler that actually that's the gatekeeper that actually is sitting in the core that allows for that access.
What happens if I take that SIM and put it in a different device?
So we actually have ability to go ahead and actually map the control of where we can take a look at your phone, MZ number, and actually put that onto the pack, into our core as well. So we can really secure that level of access. And I'll talk about that when I get to the private network as well. So let's say if you actually take a phone out there, take a SIM and actually put it into the phone, for you to talk on a private network, you actually have to have a phone that's CBRS enabled as well. So which means we can have control over what we allow on our network.
Can I extend that question just a little bit? It's Bruno Holman here.
Hi, Bruno.
You talked about the devices that don't natively have Ethernet ports, so you got to buy your gateway. Is there, using that device, that security would be on the gateway device? Is there any way to prevent, devices that are plugged into the gateway device from being changed out, a secure device for an insecure device?
Yes. So this is where, let me just also give you another view as well. So we are now dealing with the technology that actually is evolving. So, I mean, CBRS spectrum that was actually, just rolled out in 2020, and that's where all this evolution is actually happening around that. So we would actually see the device capability to increase on, for example, if you take a look at your iPhone 12 to iPhone 13, they are now CBRS enabled. So, iPhone 12 actually has CBRS that supports LTE. iPhone 13 supports both LTE and 5G, so 4G and 5G. Now, back to your point of how do you really go ahead and actually secure the physical aspect of it, where somebody can just take that and actually plug some other equipment in and to go ahead and actually gain access into your camera or into your secure setup. Now, this is where one thing we actually do is that the devices that actually are connecting to the network, we have ability to go ahead and actually take a look at control the device connectivity based on the SIM, and also the manufacturer and the serial number that's actually built into that device itself. Now, of course, And I have a slide which actually talks about some of the vulnerabilities that are in the cellular network, and and how we're working around that. But you have ability to go ahead and actually really control in terms of allowing access based on the SIM, the vendor, and the SIM that's and the serial number that's associated with that device itself.
Do you support the eSIM, and do you think that it will prevent the SIM card copy, let's say? And do you think it's a protection mechanism for that? And if so, how do you connect the devices that do not support the eSIM, let's say, like the clients? I mean,
very good question, Rati, as well. So basically, eSIM is supported by many devices that are out there, and again, I believe that now we have Samsung devices that actually comes with eSIM capability. Now, of course, again, it's a technology that's evolving. You do actually have better control of actually managing the copying of the SIM, because this is something that you can go ahead and actually give it for, in terms of how you roll that out and how it actually gets copied over in terms of there's no physical chip that you actually have for you to go ahead and actually read out. And also, let's say, as you go ahead and actually shift devices, or you actually have different owners. So let's say, right, you have a device and it's owned by you. Now I, as Ravinder, get access to that device. For me to go ahead and actually get access to that, or let's say when the technology person actually hands that over to me, he can just simply go ahead and actually enable a different eSIM on it. So to your point, yes, it actually adds on to the layer of security by using an eSIM. That is correct. But again, the verdict is actually out there, because this eSIM technology is actually evolving. We all are learning as we're growing with this. So now, of course, we have seen that cellular technologies actually have evolved from security standpoint, and 5G is not any different. 5G actually has come up with some more advanced security feature that actually built in, and 3GPP was very, has worked aggressively. And I mean, if you go to their standards, they actually have really published quite a bit of paperwork around what they are enhancing in 5G. And I just took the release 15 notes, and actually, I've captured some of the highlights here. And of course, as they go ahead and do release 16, I mean, they will probably have more enhancements to it. But to start off, and just to name a few, primary authentication. So this is when we are talking about, typically what actually happens is you go ahead and actually authenticate a user. This is where it's a mutual authentication, where it's not just the network is authenticating a user actually is also authenticating the network as well. So that's one big change that's out there. Secondary authentication is around how the communication actually has to happen, where the traffic goes from 5G into a Wi-Fi calling or to another operator. It actually allows for a secondary authentication using MFA or assert-based authentication. Interoperator security is, and this was a case that we actually had seen with previous cellular technologies, when you actually go away from your home network, when you're roaming in some other country, some of your information was actually out there in the public in terms of how it was actually transmitted. This is where they have really honed in onto the privacy aspect, where let's say me as Ravinder goes to another country, my phone would not go and actually publish my identity as Ravinder. It will go ahead and actually probably give some pseudonym, and now that pseudonym is then validated by my home network, and then the communication actually happens. Another key change was that they actually have put multiple layers of key hierarchy, which simply put that when different segments that I had shared before have different keys. So let's say if one key does get compromised, does not mean your entire network is compromised. And another big change, and we actually saw technology changing from 2G to 3G to 4G, and now in 5G, where the radios were all together, but in 5G you actually are seeing where there's a distribution of the radio itself between the CU and DU, and that's another layer that actually has been seen by the experts in this to go ahead and actually say that actually allows for a better security in terms of managing the security control for access into your network. Now, of course, a lot of security aspects have been looked at, but so is the innovation to go ahead and actually get into the secure networks, right? And if we take a look at some of the threats that we actually have seen, And when I go through the slide, let me just do highlight this. When these compromises that are seen across, not that somebody actually broke the code or somebody broke the security specifications for 4G or 5G. It's just that they actually found a way around it. It's actually, it's not just simple social engineering, but it's basically in terms of how people are playing with the entire communication protocol and actually leverage the weakest point to go ahead and actually gain access into the setup. First being, just simply, physical, you go ahead and actually get access to the device itself. And the other two that we actually have seen is where you have seen rogue base stations that are enabled. And when rogue base stations are enabled, you actually have the devices that then are actually told to go ahead and actually shift to a lower generation of technology, which actually has a weaker security, and hence your device gets compromised. Now, there are ways around that where you could go ahead and actually use your mobile device management to actually ensure that you are telling your devices to go ahead and actually always be on 4G and 5G, so that you don't go ahead and actually move to the previous generation of technologies. And last one, the availability attack. It's simply put, where a lot of devices users are trying to go ahead and actually get into your setup, right? So that's something that can be controlled in multiple ways. One of the things is to go ahead and actually put the max connections, but other is to go ahead and actually allow for zones to be set up, and our network slicing, where you go ahead and actually allow for your critical use case application is limited to your mission critical users as well. Okay.
If you own the devices, you can own SIM cards, and you can use an MDM. I can see that as all mitigations.
Yep.
How do you prevent a SIM card being stolen or cloned, right? A device being cloned so its serial numbers match, but it's a compromised device or an attacker's device. How can you detect anything like that?
So when
what's happening in your SOC that says, hey, a blip happened to the device, its SIM was removed or something of that nature?
There's a lot that a technology does, but it does not do everything, right? And this is where, when we talk about security, we actually have to talk about how we implement our security policies around managing such situations. So
do you have any behavioral analysis of the devices so you know that normally that will never happen, will never blip like that? What's in the SOC to say, hey, we have a problem, let's catch it, let's basically disable that part of the network, for example, until we can fix it?
Absolutely, Edward. So I was trying to go ahead and actually get to the tools aspect, and I'll talk about that in my next section.
Thank you.
But I do want to go ahead and actually do bring up to that point is, Edward, that we actually believe that yes, technology is something that actually addresses some of the key aspects of how we're securing the setup. But how we actually have created the ecosystem with our peoples and policies, that's another thing that actually will allow for that. But to your point, yes, we have tools that actually allow us for behavioral analysis and does the anomaly detection based on, Ravinder should not be actually accessing this phone from geography, which is not US, right? So we have tools that actually allow for that for that behavior to be detected, and then of course give that recommendation to our SSOC.
Question about the key hierarchy you mentioned before in the previous slide.
Yes.
Can you elaborate more how it works? You say that if the attacker gains the control over the part of the network, it doesn't mean that he access to the whole network. So how does it work? The access points are configured with the different keys, or it's a separate thing?
So basically, let me just go back. And I'll just take 30 seconds on that, okay? So basically what it simply means is that you actually have, as I mentioned, there is a key that's there in the secure device, and then there's a key that's the K key that's actually there that actually is in your SIM. and then you actually have that same K key that's actually put in your core itself. Now, what actually happens is for your RAN and for your different elements, it uses that to kind of create a separate keys for each of that communication. So it's not like you're loading multiple keys, but it actually derives different keys based on the key for that subscriber that's actually loaded onto the port itself.